Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our 86th CoCoRaHS Weather Talk webinar. Very warm welcome to all of you joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from the Colorado Climate Center here in sunny Fort Collins, Colorado. All of our Weather Talk webinars are sponsored by the generous donations from listeners just like you. Well, today's webinar is presented by Tim Brown, Director of the Western Regional Climate Center at the Desert Research Institute, known as DRI, in Reno, Nevada. He will present a narrative and perspective on wildfire, the good and bad, and its relationship with society. Tim conducts applied research and application development at DRI. His primary academic interests include wildland fire climate and fire weather connections, the tongue twisters here, the wildfire environment, application development for wildland fire management planning, decision-making and policy, the interface between science and decision-making, and user engagement through the deliberate co-production of knowledge. There we go. Long sentence there. Originally from Illinois, Tim is a good friend of CoCoRaHS founder Nolan Duskin, and a good friend to all of us here. And Tim, one of his interests, he is an avid gardener. And so, Tim, we want to give you a big CoCoRaHS welcome, and it's great to have you with us today. As we start off today's program, we always ask this question, and it's kind of an interesting one. We find very similar experiences with folks. How did you become interested in weather, and then especially wildfire?
Yeah, thanks, Henry. Hello, everyone. Well, I grew up on a large grain farm in East Central Illinois. And I think as farmers, and if any of you are farmers, gardeners, you're well aware of the dependence on weather. So it just simply started there by being outdoors in that environment all the time. As for fire, that's a bit longer story, which I won't go into the details here, but that actually came about at a softball game here in Reno, Nevada. So that's my history.
Oh, you have to elaborate on that softball one. We're giving you we're throwing you a softball there. Tell us, Tim, a little more. That's fine.
No, basically, so the Weather Service has a group of meteorologists called incident meteorologists. And these are folks that go out on wildfires. They could be called up, particularly for these larger incidents. They also do all hazards kind of incidents as well. But when I first moved to DRI, this would have been back in the mid-1990s, trying to find my way around here. So, what do you do when you move to a new town? You form a softball team. And my spouse was the science and operations officer at the National Weather Service here in Reno. And so we formed a team between the National Weather Service and DRI. We called it DRI Weather, or dry weather. And it was talking to that incident meteorologist. I saw and learned things about fire and realized opportunity there. And the one thing I can say about that is, remember, this is back in the late 1990s. Fire and climate was not a thing then. This was a very, very new areas. So over the years now, of course, it's a very big deal. So I've been doing this for a while.
Thanks, Tim. That's interesting. That's really neat to see how that came about. I was always curious. Well, we'll let you take it away for now, and we'll come back when you're finished with the presentation with questions from our audience. And again, thank you for being with us today.
Again, thank you. And I think we got full screen mode now, correct?
Yeah, looks good.
All right. So everyone, welcome to the 420 millionth 2023 year of biomass burning on Earth. I like to be precise, but the 420 million, where that comes from is that's the best estimate that we have right now for when biomass was consistent enough and available enough on the planet along with lightning to create fire. And you can sort of estimate, you can go back a fair bit of history, like through charcoal records and whatever, but that requires a lot of paleoclimatology and a lot of basically analysis to consider, well, just, when did the plants, when did vegetation actually get going? Okay, so I'm going to show you a map here. This is from last year. This is a satellite image of the amount of energy that comes out of fires globally. So this will give you a chance just to see where all the places are that fire happens. And these are not all wildfires by any means. There's a lot of agricultural burning here, among other things. And there's two types of fires that we'll talk about today. There is the wildfire, which is what you will see on the media a great deal. But there's also prescribed fire, which is the planned burning of fire to help return ecosystems into a desired condition. And then there's all the agricultural burning. And then in some places, of course, if you think about the Amazon region, there's a lot of land clearing that can be done, or that is done. So this is burnt for agricultural kind of purposes. But the main thing to realize here is that fire is global. Things that we talk about in the US in terms of fire, you can pretty much say the same thing in Australia. You can say, of course, about Canada. I'm sure you're all aware of the news of or maybe even experiencing the smoke coming down from Canada. And by the way, if anybody notices that smoke has a maple syrup kind of flavor to it, let me know. I'm trying to keep track of that. And the Mediterranean region of Europe, of course, is another big area where fire really impacts society as well as the landscapes and the ecosystems. This is a very complex picture of fire, and it's complex on purpose because fire is, in my opinion anyway, the most complex socio-ecological kind of system that exists. Because we've got the elements of, there's the landscape itself and everything about fire, all the fire physics kinds of things, like the intensity and the spread and the flaming, all that. You've got your weather and climate component, which is the ignition sources. Of course, topography is very important. At least that's the one thing that doesn't change, at least on the time scale we're talking about. But everything else that you see on here is a constant changing thing. And these are the societal impacts, the environmental impacts, the ecosystem response, the economics, how fire management tries to deal all this through both pre-suppression, suppression, and the fuel management. So if you really want to understand the full holistic picture of fire, this would be the diagram to start with. So I'm going to tell you a story about fire here, and I'll do this in chapters. So chapter 1 is a fireplace for climate. And this will be the section where we talk about how climate impacts and is related to fire. And we start with that because there's a confluence of three things that really makes fire. It's climate, it's people, it's fuels. You're here right in the middle of this. And of course, humans play a big role in all three elements of this, particularly the people part. But from the climate perspective, the climate change perspective, I mean, we know that it's anthropogenic greenhouse warming. That's the main factor. And fuels, of course, there's natural fuel variability, but you'll see a little bit later when we get into that section that humans also play a major role in what the fuel situation looks like out on the landscapes. So a few things about the climate. I'm going to focus primarily on this concept of fuel aridity. And basically what this means is if you're going to have fire, the fuels have to be available to burn. So they have to exist, but the fuel moisture has to be available to actually burn. So this is some research and published in the Proceedings of the National Academy of Science a few years ago. All this means is really all I want you to see here is that each of these maps, which represents a different type of fuel aridity factor. So there's drop indicators on here, there's fire danger indicators on here. They're all red, which basically means that the Western US in particular, this paper happened to be Western US centric, have been drying over this period starting in 2000, 2015 through that time frame. So we have the observations to tell us that climate and its relationship to fuels has been changing in a way that is enhancing or exacerbating fire on the landscape. Especially out west, although the Midwest and other regions are not immune to this, is this concept of mega drought. Here's the paper just from last year showing soil moisture dating back to 1800 through near present when this paper was done. And that was obtained actually through tree ring records in the Southwest US. And you can see on here that there's periods, these are highlighted in these pink vertical lines that show very widespread drought across the region. And you'll see there just a little prior to 1600, a particularly anomalous period in terms of drought across the Southwest. But here's the thing, look at the red line on the far right, and you'll see that we have exceeded that period. And in fact, the recent drought that we've been experiencing in the West and Southwest has exceeded any of these previous mega droughts going back about 2,000 years. And what the study showed is that about 42% of the contribution to the occurrence of this drought period, again, was due to the anthropogenic climate change. So it's a combination of the warming temperature, and that feeds back on drying conditions. And so drought is really a feedback process. And it's always been that way, but what's a little bit new now in the last few decades is since it is warmer, that again exacerbates that drought. So that feedback loop is definitely making its mark known now on conditions. So we have that, and now I want to show you a video here that basically this is going to be a dry Christmas tree in a living room. And this is to give you the concept of what we really mean by this fuel aridity, drying out the fuels. So I'm just going to get this going. This is from the National Institutes of Standard Technology. You'll see a flame begin at the bottom of the tree. And within 5 seconds, that whole tree is engulfed. So now imagine millions of these kind of trees dry like this. They're stressed from drought. They're stressed from bug kill. They're stressed from overgrowth of the forest. This is very similar to what you will find out on that landscape, particularly during these more severe, bigger and more severe wildfires. Another relationship with fire, particularly in the mountainous areas of the Western US, is this concept of snow drought. You can get that two ways. You can either just have a lack of snow, or you can have snow, but you have a lot of rain on snow. And so that changes the characteristic of the snowpack. And you might not even have as lower elevation of snow line as desired. So back in 2013, the mid 2000 teens, we had a very significant drought period again in the West. So note the, I don't know if I try and point to things with the arrow, I don't know if that's actually showing up or not. I think there's another way to do that. But if you can see the Nevada,
We can see your arrow.
Oh, you
Yes.
can't see it. Okay. There's Nevada Sierra Range here. You can see the snow cover on this 2013. If we go to 2014, again, these images were composed and compiled to really correspond. So this is an apples to apples kind of comparison. We can see a reduced snowpack, and by 2015, even less snowpack. So this will be and can be a factor for how fire activity occurs, particularly in the mountain regions of the West. This year, it was the second snowiest year on record in much of the area. And so there's still plenty of snow out there in this year as I look out a window here. And so as a result of that, we're not expecting a lot of fire activity in this particular region for this year, but I'm going to come back to that at the end just briefly. All right, so how much is the planet warming? I'll let you watch this spiral diagram going through the years. So you have the months on the outside, and then each ring represents a temperature. And what you're going to see here soon is just how much this ring is really expanding. I'll just let you enjoy this here for a few moments. And here's another perspective if you want to see that just from a different angle. So we're now reaching a global warming of 2 degrees Fahrenheit above the background, what we would consider the period of before this anthropogenic change really has taken place. And keep in mind, as I said before, now this warming is really going to help exacerbate fire conditions around the globe, and partly again through that fuel aridity, through that fuel drawing feedback. But another thing that's going on, and there's still a lot of research taking place on this, but it's intriguing idea. We know that the Arctic is warming much more quickly than every place else. And we've got permafrost melting. And of course, now we're seeing fires in the boreal region that we're not used to seeing. But that warming may be exacerbating changes in the jet stream. And so, for example, one of the things that we know the jet stream does, it creates things like the heat domes. And we a while back had one over the west, over northwest British Columbia. This year we've had that over like Texas and some of the central US. So the jet stream seems to be getting more wavier, and when it sets itself up, if it sets up what we call a ridge pattern, then that could really dry out conditions underneath that pattern, and again create the potential for a lot of fire in that area. If it's a wet region, if it's a trough and we're getting a lot of precipitation, well, there might not be fire, but what it's doing is feeding the fuels for another year through all that fuel growth. So this idea of fire doesn't really stop. It's not strictly a drought thing. It is also a wet thing. This might look a little bit complicated here at first, but we'll simplify it a lot. This has come out of the very new Intergovernmental Panel on Climate Change, the recent synthesis report. And basically, I think what I want you to notice here is each of these global maps, they're all red, which shows warming. This one, the middle one, is soil moisture. If you see the browns, these are places where drying is expected. The greener is where increased wetting is expected. And then the very bottom one is more about extremes in precipitation. And that's one of the anticipated outcomes of this climate change is we'll have more dry events, but when we do have wet events, they will be wetter. So this particular map corresponds to if we increase the world 1.5 degrees C, 2 degrees C, 3 degrees C, and 4 degrees C. I mean, we're interested in this kind of analysis for a number of reasons, but today we're focused on fire. So one of the things that, we all want to think about is, well, what does this mean for fire potential? What does it mean for post-fire recovery? What is vegetation going to do after the fire? Will that forest return to something similar to the way it was, or will it be invaded by a whole new species? And then, of course, there's the other impacts related to that, which, for example, would be the wildlife, the impacts on watersheds, and that sort of thing. A scary analysis, from my perspective, this is one of the this would be one of the more extreme climate scenarios by the end of the century. Basically, all you really need to pay attention to here is that most of the US by the end of the century, if we continue on this path that we're on, will just continue to dry out more and more. And remember, we talked about that mega drought a little bit ago. This particular analysis went back to the year 1000, but basically the same concept. This graph here is Central Plains, the Southwest, and here's the projected soil moisture conditions compared to a near recent anomaly like this kind of a normal period through here. And then here's what the models currently suggest this could look like by the end of the century. That's a lot of drying. And it's, you can easily imagine what that could do for fire, but obviously that will have a lot of other societal impacts as well, such on agriculture and water resources and so forth. Some of our own research here. So nighttime fire behavior is just as important as what goes on during the day. It used to be nighttime was the opportunity for fire management to do certain suppression practices because during the day, the atmosphere is heated up. You have a lot more convection. The fire is more intense because of the sunlight, because of the daytime drying. But at night, when it cools off, the atmosphere can become more moist. And so the fire would tend to lay down, and that would allow certain fire management strategies to take place. But we're starting to see more and more nighttime events that's difficult to employ these strategies at night and to help gain that control. And all we're looking at here is the change. This is another indicator of fuel aridity. And so even over just the, this is the observed period, basically. So a little bit of the future in here, but we're just seeing this very pronounced drying of the fuels at nighttime. And if we look at the models on this, for most of the models, we anticipate a continued of that drying. So all of this is fitting together these different ways to look at climate change and how they're impacting the environment. And finally, the last thing on this is more of a global thing, but when you do put all this together, basically there's an expectation that we're just going to continue to see more and more of these larger, more significant wildfire kinds of events. So that's the climate background. I'm going to now give you a little bit of the fuels background in a chapter called How Not to Be Seen. So here's a forest, the Bitterroot National Forest, a picture that was taken back in 1909. Notice that the forest is very open here. You can actually see folks riding horses here in the background. Here's a person standing here by this tree. I'm going to say it's a graduate student. I don't know for sure, but and whether this forest had been treated or not, that's very much a possibility. This might not have been a natural state of the forest at that time. But the important thing to note here is its openness. Because if we advance 40 years where fire was excluded from this landscape, you can see how it is starting to fill in. Here's that same tree. The photo was taken from the same location, probably the same grad student, came back, take a look, see what's going on. And then 40 years after that, you don't even see the tree. It's all filled in now. And by the way, I do think that graduate student is still standing back in here someplace. So this is a lot of fuel growth over this period. And this is exactly what happens when you do not have, when you remove fire from the landscape. And we need to realize that, first of all, fire is very natural across most landscapes in the US. And even if it doesn't naturally occur, say, by lightning so much, it was long managed by Native Americans. And so indigenous communities managed the landscape for thousands of years. But come the early 1900s, and especially by the 1930s, a very aggressive fire policy began happening, especially on federal lands in the Western US. And that and a combination of climate conditions allowed these fuels to really build up. And I mentioned before about, you can look at tree rings. And first of all, you can look at tree rings as a proxy for drought indicators, such as soil moisture. But if you have low severity fire, that is fire that will burn around the tree trunk, it'll burn the grass and the shrub, but it's not a hot, intense fire. It will leave a fire scar in the tree trunk, but not damage the tree. And so researchers, wherever they can, will take samples from these, and each of these dark lines is a fire scar. And in this particular case, the earliest one in this tree, 1765, and the last one in this particular trunk example was 1889. So you can date these events. So if you do this over an area, this graphic is for the Lake Tahoe Basin region. Alan Taylor at Penn State University has done a lot of work in the Jeffrey Pine Forest up in the basin, looking over different areas, different groupings. But basically the thing here to note is each one of these triangles, each one of these lines represents fire, around the basin. And clearly, there's something really obvious happens here. In the mid to later 1800s, there's no more of this. And you can see other examples of this in other parts of the country, but in this particular one, well, the question is, what happened? Is this strictly fire exclusion kind of a thing? Well, it turns out it was the gold and silver rush, because that endeavor was very heavy timber intensive, and basically all the forest in the basin was cut down. So there's very little old growth forest up around Lake Tahoe. If you've been out to visit or you come out to visit, what you're seeing is actually a young forest up there now. This is what it looked like at Spooner Summit in 1873. Here's Prairie Meadows in 1873. And you can see, yeah, again, a lot of cutting there. The railroad is something that required a tremendous amount of lumber, as did building the mine shafts around the region. There's an inset there for Prairie Meadows. So again, that's what it looked like in 1873. And here's what it looked like in 1993. So again, fire had been excluded. And just yet one more example of, if you do that, then you're just going to have this massive fire growth, or the massive vegetation growth, to increase the potential for these more extreme fires. So a lot of folks will look at this today and go, oh, isn't that nice? That's a really nice looking forest, all these trees. Well, another problem though is that this density, and it's going to depend on the forest, it's going to depend on the geographic area of what's going to be appropriate. But we're finding that a lot of these forests are overgrown. And if drought comes along, increasing temperature comes along, it really stresses this whole environment. And so even the stronger trees now are stressed out as opposed to, or in this case, right, everything can get stressed out. But if you have a lesser density forest, then the trees, it's easier for them to find water because the competition is less for the water and the nutrient sources. So here's a forest in Utah. This is a mixed conifer. There's a lot of disease in here. Given time restraints here, what I'm going to tell you is, I'm going to show you now some video. I'm going to put you inside this forest and we're going to set it on fire. As a prescribed fire, you can burn these very dense areas depending on what your management objective is. And in this particular case, this is Fish Lake, Utah. This forest shouldn't be looking like this, right? This is another example of that fire exclusion. What this should be is some conifer, but it should also be a lot of aspen in here. And that's been totally taken over by this environment. So there's a big program underway to do these large-scale fire experiments where we measure the fuels, we measure the fire behavior, we measure the meteorology, we measure everything about the plume, we measure the smoke and the chemistry, all these things from a single fire. And so this is an image prior to that. So what I'm going to do now is some cameras, a couple of cameras were placed in this forest, and then the land management, per the design of the prescribed fire, lit this up. And so I'm just going to let this run through, and you can start to imagine all the things about what could go on inside of a wildfire, even though this is a prescribed fire. This is real time, by the way. There's no speeding up for this imagery. Well, did you enjoy that? But that's what it's like to be in a wildfire. What did it look like after? This is the landscape. So here are the two camera systems that video was taken from. But what I want to highlight here, this looks like, and I just realized I forgot to put a slide in that I meant to, which showed that the prescribed fire worked. So this looks very devastating. And in fact, a lot of wildfires will look like this afterwards. But the aspen started growing back very nicely within 6 months. And so those trees, those seedlings that were just lying dormant on the ground because they couldn't go through all that heavy fuel, were very appreciative of what fire management did for them. But another reason to show this is this gives you a little bit of idea now to think about what happens after a fire. I mentioned in this case, the aspen came back, but there's another thing that happens that's getting a lot more attention these days because we're starting to see the potential for a lot more of these events, but it's called the post-fire debris flow. And so back in late 2017, there was a fire in California called the Montecito Fire. And what had happened after that fire in early January, it was just a heavy rain band came through. And it dumped 1.03 inches in 15 minutes. And it all fell on that burn area called the Thomas Fire Burn. And the image here shows you what happened as a result of that. If that vegetation had been in place or had that been a healthy ecosystem forest environment, this might not have looked as bad as it did and caused the kind of damage that it did. In this case, 23 fatalities, over 200 structures destroyed, and the closure of Highway 101 for a couple of weeks. So that's the fuels part. And now chapter 3 is how to be seen, the opposite. And I'm going to introduce this by going back to October 2017. There were a series of Napa fires that occurred during a windstorm in which the power lines actually started these fires. In the end, there was 44 fatalities, over 8,900 structures destroyed, 90,000 evacuations. At the peak deployment, there's 10,000 firefighting personnel and at least 9 billion in insured losses. This is a map of where those fires occurred at that time. Now, I got a little note here that in 1964, there was some fires with 306 structures destroyed and $4.75 million in damages. Well, why is that? Let's focus on this Tubbs fire right here. It turns out we're calling these the two Santa Rosa fires. The black line is that Tubbs fire, the perimeter of that Tubbs. The red line is that 1964 Hanley fire. Very similar burn perimeter, very similar pattern. And this helps you realize that fires occur naturally, certainly in this region, but as I mentioned before, across many landscapes. So if we're starting to have more damages, societal impacts and damages, well, then where is that coming from if these fires occur naturally here anyway? Well, here's that Tubbs fire perimeter. This is the housing units per square kilometer in 1940. So the darker the orange, the more the housing unit. 1940, 1960, 1980, 2010. The bottom line is we humans are moving in to the places where fire occurs. And this is your primary reason why we're seeing or hearing more about these very destructive fires that are getting into these communities and causing considerable damage. If you look at the national map of where you have primarily human ignitions versus primarily lightning ignitions, the red is human, the blue is lightning. So the east, except here for the southeast, which is kind of a 50-50 thing, especially in Florida, southeast a little bit. The east is primarily about human ignitions. California is primarily about human ignitions, except for the northern part and the Sierra Nevada range. Here in the interior West, it's more about lightning. And if you look at detailed maps of fire starts, you can see that a lot of these fires are just outside of communities. They follow roads. They used to follow the railway lines many years ago. Not so much of that now. But wherever humans are, you'll probably find a fire start. So that was a quick thing about the humans. So think back then to that Venn diagram I showed, those three circles, and how those three together, that's again why we're right in the middle. But here's another way how not to be seen: smoke. And this is very much in the news today. Wildfires puts out tremendous amounts of smoke. Here's an image from British Columbia in 2021. All this smoke. Here's September 1 of 2021. California, Nevada. So this was two very large fires that year. The Caldor fire. I'm going to come back to that one briefly in a little bit. But you can see that was nicely putting smoke into Reno. I've long said that Reno's the smoking section for California. And so here's an example of that. The Dixie Fire, a very large fire, nearly 1 million acres burned in California. In fact, this is so large, this is the same fire. This just happens to be now the main hotspots are in this part of the fire, northern part and the southern part. And by the way, a side note, you will hear a lot about acres burned or area burned. The instant thing to do is think that's a negative thing or a bad thing, and that's just not always the case. Acres burned it's a very easy metric to come up with, but it's actually not a very useful one for most purposes, because there can be a lot of fire in these perimeters that's not a high severity fire that's doing a lot of damage. And that doesn't especially get separated out in the news stories. But yeah, think about that when you hear somebody say, oh, that's a huge fire with this many acres. Maybe it's all been bad, but more than likely not every single acre is a bad situation. And of course, what's that impact on humans? I mean, this is 2021. I probably should look and get an updated one to show the East Coast for this year. I probably will here at some point. But yeah, you can see how widespread these areas can be. So these are all these oranges and reds are very unhealthy. We can see how easily it can be transported. The East has gotten wildfire smoke before from the West. Some of this has made it to the surface. Some of it stays fairly high up. It's not difficult for the smoke from some of these larger fires to travel around the earth and come back. In this case, this year, a lot of the smoke is at the surface, unfortunately, and impacting now some of the Great Lakes region and central area, and of course, the East. So here's that Dixie Fire. This is a time lapse now from a wildfire camera. And just, there's a lot of things going on here. First of all, notice the density of the forest, but also how these fires build up like thunderstorms. This is a pyrocumulonimbus type cloud now. that's a result of the heat and moisture emanating from this fire. You can actually get lightning out of these things, so that becomes a safety factor for both firefighters and the public. You see a lot of smoke coming out of this, but there's a lot going on, and this is just like 3 hours in an afternoon. This fire went on, it was at least 2 months. I don't remember the exact long period of it, not all at this kind of intensity. But when you got fires this big, you're pretty much waiting for winter to come along and help you totally extinguish that fire. So pretty dramatic to watch this in real time. Of course, you could put yourself as pretend you're a fire manager, making plans on how you're dealing with all this and all the resources that might be needed and all those types of things. Okay, chapter 5, I'm at a loss. And what I'm referring to here, now we're going to talk just briefly about societal impact sort of thing. The cost of wildfire in this particular case. I'm going to show you 3 of these, but not to go into lots of detail. Basically, though there's 2 types, there's direct costs and losses for these different kinds of categories of groups, from homeowners, fire departments, businesses, and the direct kinds of things will be the deaths and the injuries, the psychological impacts, the structural losses, all these different kinds of losses, and then what it might take for the remediation or the cleanup. But then there's a couple of sets of these indirect costs, and we do hear about some of these. You will hear sometimes things about the business interruptions, especially on tourism, but there can be supply chain issues. I think we're all very familiar with that now from the last few years, at least that concept. The evacuations, utility kind of interruptions, transportation interruptions, those sorts of things. There's housing market impacts, loss of ecosystems, increased risk of other hazards. I showed you that one picture of debris flow. So again, lots to think about here, and going back to one of those early slides I showed you, just how complex fire really is. In 2022, I haven't seen an updated version of this, but the First Street Foundation put together a national wildfire probability map, basically highlighting places where risk at different levels. And in 2022, there was nearly 80 million properties at risk from wildfire. And this shows you the map of where all the places are located. And this is most of the country. All the west, getting into the central areas, some of the upper Great Lake region, and of course the southeast. So I might have portrayed a lot of negative things there, but there are a lot of things that can be done if we choose to do it. And I'll make the point that solving the wildfire problem, whatever that means, putting solving in quotes, it's not a science or technological issue. It's a political and societal will issue, because we do know how to do a lot of things. There's lots you could do in zoning. Risk mapping, just identify areas like the map we just saw. There's a lot more of that going on. Lots can be done with mitigation, community mitigation, individual homeowner mitigation. And I'm going to show you one example shortly on forest mitigation. You can't go wrong with public education and information. And of course, all this, we have to think about firefighter health and safety. So the forest mitigation example I wanted to show you is that Caldor event, over 1,000 structures destroyed. All of South Lake Tahoe was evacuated. This is shows you a 3D perspective of where that burn perimeter was with South Tahoe. Reno, Carson City, that's all just over here on this side. But here's the thing I wanted to show you, and this is why prescribed fire is so important. So this is a portion of South Lake Tahoe. You can see in here the forest, but you can see houses. So this is the neighborhoods of South Lake Tahoe. There was fuel treatment done in this area. There was no fuel treatment done up in here. We can see what the wildfire did here. It didn't make it into here. And that's because the fuel treated area allowed crews now to work this much more easily. Basically, this helps be a fire break and reduces that high severity fire coming into communities. So if you hear more and more about prescribed fire, it's a very important tool to be used. And all the agencies are trying to increase its use around the country. All right, chapter 6, nearly the end of the story. This is what our 2023 situation looks like. Now, these maps were issued at the end of May. There'll be a new set come out on July 1. I don't know exactly what they'll look like, but two things here. One is to know that a lot of effort is put into seasonal wildland fire potential outlooks. The red areas are those places that's thought could have more extreme activity, above normal activity, the green below normal activity, the white area, a typical year, nothing to think about too much. So what folks are really looking at this summer is going to be here in the Northwest, particularly the Pacific Northwest area through the summer, but also this Great Lakes region and even getting up here into Maine. And of course, we know that there's fires it's already been occurring up here in like the Ontario region. You can find these if you just search this and you want to see these for yourselves. You can search Google online or whatever your favorite search engine, and probably would find these pretty quickly. The last thing here, back in 2021, I mean, we've been talking about climate change, and it seems like there's always these stories about things that we haven't seen before. 2021, smoke from the Boreal region actually reached the North Pole. And as far as we know, I mean, it's the first time in recorded history anyway. And here in this satellite image, you can see this darker area reaching the pole. Well, I had to think about what could that mean for a human impact. And so I was able to obtain a couple of pictures. Here's Santa and Santa's village. And then here's what it looked like when the smoke hit. Okay, so I gave you an awful lot of stuff there as an overview. Can you see the forest for the numbers still? And Henry, I think that's it for the show.
Well, thanks, Tim. That very, very informative. This is a lot of stuff we didn't know, and I know our viewers appreciate it. And thank you for taking the time to put this together, especially, I think a lot of people now with all the smoke this year are really thinking about wildfire, especially in the East where they haven't experienced the smoke that we've had in the West over the last couple of years. So it is very timely to have this webinar right now. We're going to take some questions from our audience out there. And so if you would like to send Tim a question, put in your name and where you're located, and we'll try to get through these here in the next 20 minutes or so. There's one that just came in here, which I think is pretty interesting, just what you were talking about with the polar regions. And Volker was wondering, what is the impact of the present Canadian fires on blackening polar ice, and what would happen with that?
Yeah, that's a very good question. I haven't seen anything yet regarding that, but overall, yes, that is an issue. It's called black carbon. And what happens is if that gets on the polar region snow and ice, it darkens what we call the albedo, or the reflectiveness of that. I think you're all familiar with, if you have a a lighter color object. It reflects heat more easily than a darker colored object. And so what we're talking about here is increasing the ability of absorption of the solar sunlight radiation and helping to heat up the polar region and creating, increasing melting of the ice and snow.
Thanks, Tim. And here's one from Scott in Portland, Oregon. And he was wondering, what is the impact of clear cutting with condensed replanting of new seedlings after in an unnatural pattern? So maybe they're clear cutting and doing this, but then they're not putting the seeds in where the right type of pattern.
Well, so there's two kinds of forests. There are plantation forests, and then there's the natural forest. In terms of putting the seedlings back in a natural pattern, I'm assuming you mean kind of a random pattern, which means there can be clumps of trees in a random pattern and then some space and then a single tree kind of a configuration there. I don't explicitly know about how folks are necessarily replanting because I think that's going to be dependent on the forest itself or the landscape that they're working with. I think the slope and the aspect of the terrain would probably be a factor in that, as well as what is being put back. In other words, what plant species is being put back in. So I think those are the factors, but it's going to depend on, I think, where you're at and who's actually doing the work.
Okay, here's an interesting question and something you brought up earlier that I'm curious about too. Sharon in Cumming, Georgia wants to know, can you explain the maple syrup taste and the smoke? You were interested in that, and could you go elaborate a little bit more on that, Tim?
Well, it was a joke.
Oh, okay.
No, I don't think there's, I doubt that there would seriously be anything there, but where the joke does come from, though, it is a real problem in vineyards. There's certain times of the year in the grape production that there can be smoke taint in the grapes, and that can be a significant impact on wineries and the viniculture community. But yeah, I wouldn't actually worry about the maple syrup. But if you do taste it, that's probably great. I don't know.
That maple syrup may have a smoky taste to it this year when you get it in the store. Yeah. Okay, here's one. Dennis in Louisville, Kentucky wants to know, is the U.S. doing anything to control the spread of the Canadian wildfires right now so that they don't cross the border, or are we helping out to suppress those up there?
Yeah, I don't have any numbers in front of me. There's likely U.S. personnel helping out. We do have international agreements with other countries. That includes Mexico, Canada, New Zealand, Australia in particular. So when a certain country gets pretty bad conditions like Canada has been facing, and so far this year, there's hardly been anything going on in the U.S., from a big, national perspective. So through those agreements, yes, personnel and resources can be traded to provide support.
Okay, here's two questions that are a little similar. Brenda writes in, and then Mary from upstate New York. Brenda is in, I'm not sure where she's writing from, but she wants to know, is this the first time, well, she's in Indiana, the smoke has hit Indiana like this from Canada? And then Mary wants to know what is causing the orange color, making everything look sepia color in the sky.
Yeah, so, well, first time, I think, first time in probably modern times. There may have been something way back when smoke would have drifted down. As I mentioned before, you've had smoke over the east before from the west, but just not getting down to the surface to the same extent that that's happening now, because that smoke is so nearby. And for comparison, this is these smoke events now in the western U.S. is not uncommon. So now what we can say is the whole U.S. now has really been experiencing these smoke events. And this is a time to highlight that folks should take this air quality very seriously, because there is a high proportion of individuals that are a high proportion of the population that is susceptible to impacts from smoke. Some of it can be just very kind of simple respiratory issues, but there's a whole range all the way to cardiac arrest, very serious health issues. And of course, if anybody has asthma, that's going to be a problem, or other underlying conditions. And this was a big deal, by the way, during COVID, right? That was a respiratory thing. And now you add smoke on top of that, that was potentially very impactful for some people. Regarding the orange, yeah, this is just the way that if you think about the sun, the light has rainbow colors. And so what the smoke does, it's just the way that it's refracting that light in a way that what you're seeing is more of the orange color through the particulates. A little bit like how you see orange, or not a little bit, I mean, it's basically similar to seeing the orange at sunrise or sunset periods, the orange in the sky.
Thanks. Here's one from Ann. She says that she's heard it's possible for some wildfires to go underground in the winter and reemerge in spring as if hibernating. Is that really possible? And the implications of that?
Yeah, absolutely. Yeah, there's well-documented cases of this. The Fort McMurray fire that was very damaging in Canada a few years ago, that actually burned, it was either a year and a half or 2 years, I think, because a lot of that wound up underground and continued to burn. But there are known cases where fire crews thought they had the fire put out under control, only to reemerge at some point later, including even next year after the winter season. And yeah, what a surprise, right?
Yeah, Brandon, right? He's from Colorado Springs. He says, we've had a very wet winter and spring here in Colorado. Isn't this a great time to do prescribed burns along the Front Range? What would you think about that?
Yeah, so prescribed fire, it is complex because, well, first and foremost, why are you doing the burn? So there's some management objective for that. It could be anything from hazardous fuel reduction. Maybe it's watershed restoration, riparian restoration, ecosystem, health purposes, something to help wildlife. There can be lots of reasons to do these burns. So first, that gets considered. The next thing is what are what's called prescription parameters. What are the weather conditions going to allow for, the climate conditions for that, and even smoke is considered, as part of these burns. They're not interested in having smoke impact a community, certainly unnecessarily. So yeah, during these kinds of wet periods, there usually is an uptake in prescribed fire. I don't know particularly about the Colorado Springs region. I do know in Northern California, this was probably one of the most active prescribed burn years that they've had in a long time, partly resulting because of the wet winter, also resulting from this understanding of an increased need to get more fire out on the landscape.
Ray in Missouri was curious about wildfire, what wildlife actually impact How do they deal with fires, both prescribed and others? How do we monitor that? So what does this do to the fauna in among these forests?
Right. So wildlife is very in tune with its environment. It just seems to know that there's something going on that's not normal, and so it will escape the area. It depends on what you're talking about. Some things simply can go underground. Some things try and run away. For prescribed fire, these are, for the largest percentage of cases, these are low intensity, slow moving kind of fires. There's plenty of ample opportunity for wildlife to take refuge. And what we see is after that fire is gone, we see the wildlife coming right back into that space and checking things out. Sometimes though, these wildfires can be so severe, and this happened in Australia recently, what they call their black summer fire, where there was an estimated like 1 billion losses in wildlife from those fires because they just could not escape. There was just no way out. So there can be very severe consequences, but it's an important thing to think about, because if we are anticipating more of these extreme wildfires, then yes, this could be more impactful on the wildlife.
Thanks. Mike writes in and he wants to know about, is a crown fire more destructive than a typical forest fire?
Might depend a little bit on perspective, but yes, because what the crown fire is doing is it is taking out the entire tree in that case. So typically the reason you get a crown fire is you've got such a high fuel loading on the ground and fuel types that creates what's called the ladder of fuels. So you might have grass, and imagine grass, and then imagine brush, and then imagine a tree, the canopy of the tree. And if these are connected enough through these fuels, then it's easy to get fire in that crown. And then the wind and the weather that a fire itself creates will move through. So there's where you're going to, that crown fire is where you'll begin to really take out the entire forest. And yeah, probably damage it in a way, although depending on tree type a little bit, but damaging it in a way that it's not going to come back. And by the way, we talked about area burn before. If we say 10,000 acres burned, that doesn't necessarily mean that. A lot of times that may be referring to the perimeter of the fire. There may be lots of islands of within that perimeter in which fire didn't really do any damage.
Okay, thanks. Jamie wants to know, is why do states have very different forest management practices? So that's a good, interesting question there.
Yeah, well, think about who fights fires. You know, from the top, we've got 5 federal land management agencies, starting with the Forest Service, but the BLM has a fire agency, the Park Service has a fire agency, the Bureau of Indian Affairs has a fire agency, Fish and Wildlife Service has a fire agency. Each state has their own department of natural resources, and under some title. Then you've got private lands, and so each of these, partly through history and partly through what is perceived as to being the management needs of their areas of responsibility, that's why we can wind up with different policies. And that can happen within the same agency. So I made a reference early on to the wildfire suppression policy of the Forest Service. It began in the around 1910 with what's referred to as the big blow up or big burn in the Northern Rockies. But in the 1930s, there was another big set of fires in the Northwest, and this led the Forest Service to have something called the 10 a.m. policy, which meant a fire that was reported today had to be extinguished by 10 a.m. the next day. If that didn't work out, 10 a.m. the following day, and so forth. And prescribed fire was essentially stopped in the West. So you can see how that led to a very aggressive policy about fire exclusion on the landscape. In the Southeast, it was long recognized that there should be prescribed fire, it should be allowed to burn because fire was a benefit to the ecosystem. And this actually came about in part because all the wealthy folks from the Northeast wanted to come down to the Southeast for their hunting trips. And they were actually, even though, I mean, you could think of it, well, yeah, they were hunting, but they were conservationists at the time. And they did recognize and appreciate how to have a healthy landscape. So even within a single agency, there were two perspectives on how to manage.
Thanks. Here's one from Nora. She mentions that you talked about forest fires. What about grass muck fires, such as the Everglades map showed serious fire risk for? And I think of the grass fires, think about the one here at around just after Christmas 2 years ago that swept east of Boulder. And so what about those kind of fires?
Yeah, exactly. So when you hear the term wildfire, that does encompass both forest and grass, shrub, basically any biomass that can burn. When we talk about wildland fire, that includes wildfire, but then that also includes the prescribed fire or the components of fuel management, fuel treatment. Yeah, grass fires will behave differently typically than forest fire. They can be very fast moving, also short-lived, although these days, because of the heavy fuel loads, we're seeing some very fast forest fires, thousands of acres being consumed, in a single day kind of thing. And the Everglades, the same thing. I mean, right, that's the biomass that can burn under drought conditions. So I guess that's the way to think of it. There are different strategies for these different fuel types, but it does all fall under wildfire or wildland fire management.
Okay, we'll just take a couple more here as we're starting to run out of time. But again, great presentation. We could go on for hours with this.
Oh yeah.
Henry,
yeah.
This is Noah. I actually want to ask a question on behalf of Nolan, who is
Nolan.
attending from his cabin in the Upper Peninsula in Michigan. But Tim, Nolan wants to know about smoke forecasting. It seems to have improved recently over in the most recent years, and he's wondering if that's an accurate observation, and also if so, what has caused that improvement in smoke forecasting, and is there any more in the future that we can expect?
Yeah, absolutely. So, hi Nolan. It has improved, and this is a result of, well, basically just fundamental research on combustion of fuels, of the chemistry of fuels, how smoke interacts, with the atmosphere. So that connection, that process, but there's still some it's got a long ways to go. It can be improved considerably because there's still this big unknown in this space called plume dynamics. And this is really this connection between, you got the fuels burning, and then you've got the meteorology and how this is mixing to create the plume itself within the fire. There's no real good modeling mechanism for that right now, to put in a model to make forecasts. And so that's a priority for researchers to try and figure that out. And yeah, there's several different smoke models out there. There's a bit more of a statistical approach, but we're seeing more and more of what we would call a dynamical approach, or a weather model type approach for predicting smoke. And another piece that's difficult is not so much where the smoke will occur, but what level in the atmosphere. And so that's a critical area as well, because will it all be down more at the surface, or will it actually rise up and really not mix down very much and make it to the surface? So if you look down on a smoke map, it might look like, oh, we're really getting smoked out. But you might come to find out, well, yeah, but that smoke is 20,000 feet above us, kind of thing, and not likely to make it to the surface. Nolan might be enjoying some of that Canadian smoke.
Yeah, I think he has. He's been telling us it's been pretty thick up there over the last couple of days up in Michigan.
All right, well, have him let me know if he detects any maple flavor in that smoke.
Yeah, he'll be looking for that. We're going to take a couple more here real quickly. Tim, you got a minute or two still?
Oh, yeah.
Okay, Rick out of New Hampshire wants to know, a non-greenhouse effect of CO2 is that it helps improve plant growth in arid regions by reducing water loss from transpiration, excuse me. Are people looking at that as a cause of increased understory that fuels wildfires?
Well, maybe, but I'm not particularly familiar with any of that work. So I don't know. This might be the first question so far that I'm not sure I have a good answer for.
Okay. Let me see. We got a couple more here coming in as we speak right now. Let's see here. Just give me a second. And oh yeah, so they were wondering here about invasive species. Somebody had written in, and let's see if I can find that question that came through. Here we go. Steve from Ohio wants to know, is there any research on how wildfire impacts the spread of invasive species like the emerald ash borer or hemlock woolly abogid?
Yeah, so there's two types of invasive species. So in fire ecology, we think of invasive species more about plants that will come in. So if you burn out, say, a forest area, one of the first things that will try and come in and come back will be grasses and shrubs first, because they're fast growing. And also the fact that, again, without fire, this fire exclusion, a lot of plant propagation, that could begin to invade an area, and some of that's caused by humans. So I can think of two easy examples. One is here in the Great Basin, where a plant species called Bromus tectorum is cheatgrass. That was brought in from the railroads, and it is all over the Great Basin. It has changed the fire regime, the return intervals of fires. It's basically messed up the Great Basin natural landscape. Another one is the planting of eucalypt trees in California that were brought in many years ago. And eucalypt trees are just full of fuel gas. I mean, they burn. They like to burn. And in fact, that's how they propagate and regenerate themselves, is through burning. So you can go to Australia and look at a forest that's burned and it looks black, and then you can come back 6 months later and it's like it's now all full with leaves again. So unless it's a really high severity fire in those forests, like what happened a couple of years ago in their Black Summer. And then there's the wildlife aspect, and I'm probably, I'm less knowledgeable about that particular aspect of it, but I'm sure there would be something there because things move around, right? Animals move around, species move around. So there's probably something to it, but I can't be specific.
Well, Tim, we're going to leave it at that for today. Thank you so much again. We really appreciate your time. Such an interesting topic, and your expertise on this and the added humor mixed in really, really appreciate that. So thank you for coming out today and putting this together. If you have any resources you want to send to us on any of these things, we can list them on our CoCoRaHS page. I know somebody was asking earlier about if there's a link to the Warming Planet video graphic. If you have something like that, we can, folks, for you guys watching out there on our CoCoRaHS page, we can put some of these resources on there, which would be great. So again, thank you for doing this today, and we will be in touch with you over time here in the upcoming months and so forth.
All right. Well, thanks for having me, and happy CoCoRaHS measuring, everyone.
So folks, as we close out today's program, we want to let you know that our next Weather Talk webinar will be taking place coming up in October. So it's going to be on October 5th, when Marty Ralph of the Scripps Institute will give us an update on atmospheric rivers. So quite the opposite of the fires, the heavy rain that's been these AARs that come across. We will have more registration information up on our website later this summer. And before I forget, when signing off today, please take the survey that'll pop up on your screen. So that is a short survey, very helpful. And so until we meet again, stay safe. And this is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now and wishing each of you a great rest of the summer. Take care.